So to finish our series of presentation today, I want to discuss a bit prevalence analysis to investigate interindividual pain differences. So I have no disclosure to report. And to start, I thought I shared a short story of how I came to be interested in this type of analysis. So picture this. I was freshly graduated, starting my postdoc with Dr. Cogill at Cincinnati Children's Hospital. And in the lab, they had this big study that Dr. Cogill introduced already, investigating individual differences in pain. And the first aim of this study was to replicate his 2003 results. So in this result, he showed, as we've seen before today, that brain activation changes depending on pain sensitivity. And this is in areas that are consistently found when studying pain. So he was basically looking for somebody to start analyzing the new fMRI data set, and he knew that I had a little bit of experience with that and that I enjoyed it. So he put me on the task, and I get started. I start doing pre-processing, analysis, and a few weeks, maybe a month or two later, I come back to him and I'm like, look, I'm finding this very wide range of pain ratings across our participant, an amazing brain response to our heat stimuli, but when I try to relate the two, I find nothing. And Bobface looked a bit like this, complete shock, and he started mumbling something like, it should be there. So I went back to work and did a lot of tests. And I went two ways. The first way was I tried to make sure that our preprocessing and our analysis were optimal for our data set and that we were not losing our signal somewhere because our preprocessing or analysis were not good for our data. And the second way I worked is trying to understand why we were not finding this relationship. And I worked on this and did tests until Bob's face went from this to something like that. So a bit more convinced, hopefully satisfied with the test, or resigned to the fact that we were not finding the relationship. And among all those tests I did, one started to pick out. And this test was the prevalence analysis. So it can be used to define the percentage of individuals exhibiting similar patterns of increased or decreased activation. So the way it works is we pre-process the data, and then we perform a GLM analysis of individual data, and we use the output cope and the individual output cope of the GLM analysis and concatenate them into a 4D data set across our participant. We then binarize and average this data set to get our prevalence. So for this, I used the sample that we've seen before today already, with 101 healthy volunteers. Participants underwent 2 sessions, and today we're going to focus on the MRI session. So during this session, participants received heat, auditory, and cold stimulation. They experienced 17 high-intensity heat stimulus, 5 high-intensity auditory stimulus, and 4 high-intensity cold stimulus. And after each stimulus, they were asked to rate their pain intensity on a VAS scale that was computerized but looked a lot like the one displayed here. So first I looked at the prevalence in our heat modality. And what we saw was quite interesting. So we found that up to 95% of our participants showed similar patterns of increased activation in really important areas like primary somatosensory cortex, the anterior cortex, and the secondary somatosensory cortex and insula. And then as our prevalence decreased, the brain areas became more peripheral to those areas. So in other words, the further away you go from these core regions, the less participants are going to show this activation. And then in the decreased activation, we saw something similar where participants exhibited, up to 70% of participants exhibited similar pattern of decreased activation in areas such as the postcingulate cortex and the precuneus cortex. And then as the prevalence decreased, this area became more peripheral to the original ones. The second thing we found that was extremely interesting for us is that up to 95% of participants were showing contralateral activation of S1, and so we can see at the top left here. But what we were not really expecting is that 50% of our participants were also showing ipsilateral activation of S1. So we wanted to understand that better, and I will step away from prevalence analysis for a couple of minutes just to show you what we can do once we see those results. So we split our groups into two. One group activating primarily unilaterally, S1 unilaterally, and the other group activating S1 bilaterally. And first I look at differences in terms of brain activation between those two groups. And I found two main differences. The first one is more like a sanity check, which I think we needed after all the back and forth for not finding the relationship between ratings and brain activation. So the first difference we found was that bilateral participant activating bilaterally had more activation than participant activating unilaterally in areas such as the primary somatosensory cortex. But in addition to that, we found that participant activating more unilaterally had increased activation of the nucleus caudet and less deactivation in areas such as the postcingulate cortex and the precuneus. So to go a bit further, I did a psychophysiological interaction to understand a bit more the functional connectivity associated with our heat stimulus. And I compared the functional connectivity again between our two groups. And we used two different seeds, so the left and the right S1 that we found in our prevalence analysis. So when looking at the result of the left S1 here, we can see that we have a significant differences in the functional connectivity between S1 and the visual cortex in favor of the unilateral part of the participant activating S1 unilaterally. And when looking at the result of the right S1 seed, we didn't find any difference between our two groups. So overall, this result really suggests that our participants process pain differently depending on their S1 activation. But let's go back a little bit to prevalence analysis. So as I mentioned before, we had two other modalities. We also used cold and auditory stimuli. So after looking at everything in the heat, we wanted to see what was happening in those modalities as well. So first I ran the prevalence analysis in the cold stimulation. And as you can see here, the picture is very different from what we saw in the heat analysis. So the maximum prevalence of participants showing similar patterns of activation was much lower, with a top of 48% for the increased activation and 56% for the decreased activation. And the activation that we see here is mostly in the white matter. And then most of the prevalence, or most of the activation, is at a low prevalence. And there is a huge overlap between increased and decreased activation, suggesting that there is much more variability in how people process cold pain. Following this, I had a look at our last modality, so the auditory modality. And again, the picture is very similar to what we saw in the cold modality, but very different from what we saw in the heat modality. So again, the prevalence was relatively low, with a top of 50% for the increased activation and 36% for the decreased activation. And most of our activation was again at a low prevalence and with a huge overlap between increased and decreased activation. So overall, this result suggests that there is a greater variability and lower prevalence in pattern of activation in cold and auditory modalities compared to heat modality. This difference between modalities could be driven by a few things. First of all, and the least exciting explanation, we simply have less stimuli and we lost a few participants in the cold and auditory modalities, and this might mean that we are lacking the power to detect those similar patterns of activation. Another hypothesis that is a bit more exciting to me would be that there is a difference in salience between our stimulus, with the heat stimulus being more salient than the two others. And because of a greater threat, kind of, the brain response to that would be more similar between participants. So to define exactly which hypothesis is correct, we would obviously need more studies with similar number of participants and stimulus between modalities. So I hope I have demonstrated to you today that prevalence analysis can be a new insight into individual differences in sensory processing and in pain processing, and it can be a tool that can be used to gain a different perspective and go further in our understanding on individual differences in pain and in sensory processing. So with that, I want to thank Dr. Coghill for supporting me during my postdoc, all our team at Cincinnati Children's Hospital, our study participants, and thank you for coming today. And we have 4 more minutes for questions. Bob, if you want to come back upstairs.